In this video, we are going to learn how to solve a system of inequalities by graphing. Now, before we get into solving a system of inequalities, let's first talk about how to graph an inequality. Now, normally we're used to just seeing y equals, which would be a solid line somewhere on your graph. But now we might see y is less than or equal to an expression, which means we would shade below that line. And if we have y is greater than or equal to the expression, we shade above that line. Now, with inequalities, we may not have an equal to symbol, and in that case, we use a dashed line to say that no point along the line is true for the inequality. Now, what is the solution of this system of inequalities? 2x minus y is greater than or equal to negative 3, and y is greater than or equal to negative 1/2 x plus 1. Now, in order to graph an inequality, we need to put it into slope-intercept form. So I'm going to take 2x minus y is greater than or equal to negative 3, and I'm going to subtract 2x. Negative y is greater than or equal to negative 2x minus 3. Then multiply each side of the equation by negative 1. Now, when I multiply by a negative, my inequality is going to flip the other direction. So now it will no longer be greater than, it will be a less than inequality. And I'll have y is less than or equal to 2x minus 3. So when I go to graph this equation, I'll have my y-intercept of negative 3, my slope of 2. And when I go to graph my line, since I have an equal to statements, I will use a solid line to go through all of the points. Now this is less than or equal to 2x minus 3, so I am going to be shading below the line. So all of that area below the line. Now the other equation happens to already be in slope-intercept form. So I'm just going to graph y is greater than or equal to negative 1/2 x plus 1 with a y-intercept of 1 and a slope of negative 1/2, so down 1 over 2, down 1 over 2. And I can even go in the other direction to get a bunch of points. I'll use my straight edge. This is equal to, so it will be a solid line through all of the points. And it's everything above that line, since it's greater than, so everything above this red line. Now, the solution to your system is where these two regions overlap, which would happen up over here on the right. And I'll really densely shade this in, but this is where all of my solutions will lie. Now, if you're not totally certain that that is your solution, you can pick any point within that system, and it should work when you plug them into both inequalities. So I'm going to pick this point right here, make it very big so it stands out. But that point is 1, 2, 3, comma, up 1, 1. That should work in both of my inequalities. And I'm going to plug it back into what they originally looked like. So 3 in for x, 1 in for y. And by doing so, I'll get 2 times 3, which is 6, minus 1 is greater than or equal to negative 3. 5 is greater than or equal to negative 3, so that works. Now I'll plug in 3 for y, 1 for y, is greater than or equal to negative 1/2 times 3 plus 1. So if 1 is greater than or equal to negative 3/2 plus 1, which means that 1 is greater than or equal to negative 1/2, which is also definitely true. So meaning that this is the correct region to shade in. And since there are multiple points in this region, oftentimes we'll use a graph to show all the possibilities. So yes, I could have picked any point and they would all have been correct solutions to that system of inequalities. So there are an infinite amount of solutions that can work, but only within this region that we have shaded. Now let's look at this other system over here on the right. I have x plus 2y is less than or equal to 4, which is not in slope-intercept form. So I will solve for y by subtracting x. And you see here, even though I subtracted x, that doesn't flip my inequality. It's only when you multiply by a negative does your inequality flip. I'll divide by 2, so y is still less than or equal to negative 1/2 x plus 2. So I have a y-intercept of 2, slope of negative 1/2. And I am less than or equal to, so it is a solid line. And being less than means I shade everything below that line. Now my other equation is in slope-intercept form already, so I have y is greater than negative x minus 1, which I have a y-intercept of negative 1 and a slope of negative 1. So down 1 over 1. And I can go backwards as well. But in this case, I won't use a solid line since my inequality is not equal to. So this will be a dashed line. It looks like it goes on and intersects up here somewhere. And now this is greater than, so I'll shade everything above. So it looks like all of my solutions exist in between the two lines where the shaded regions intersect. And this time we have a very easy point to check, because within my shaded region is the origin, 0, 0. So I will check the points, 0, 0. Which will give me 0 plus 2 times 0 is less than or equal to 4, which means 0 is less than or equal to 4, which is absolutely true all the time. And if I plugged in 0, 0 into the other inequality, I would get 0 is greater than negative 0 minus 1, which means 0 is greater than negative 1, which is also always true. And that is how you solve a system of inequalities by graphing. And a key thing to remember is that the solution is the shaded region, meaning every point that exists within that shaded region.